Define the term electronegativity. It is the tendency of an atom to attract a shared electron pair in a bond. With reference to electronegativity, and that's really important, you have to talk about electronegativity when they say with reference to electronegativity. Explain why lithium on the periodic table forms an ionic bond with oxygen, whereas hydrogen forms a covalent bond with hydrogen, at least with hydrogen. So, what are we going to do? The first thing is to look at electronegativity. It's quite easy. So I'm going to go and I'm going to look at the EN difference between lithium and oxygen. And I'm going to say that is going to be equal to 3,5 from oxygen minus 1,0 from lithium, and therefore 2,5. Therefore, ionic. And notice I haven't written a long paragraph. I've got right to the point. And if I'm going to go hydrogen and oxygen, my electronegativity difference is going to be 3,5 from the oxygen minus 2,1 from the hydrogen, and I'll end up with 1,4. Therefore, covalent. 4 marks. Done. 1, 2, 3, 4. You had to refer to electronegativities, and therefore, when you're looking at ionic and covalent, it's electronegativity difference. With the aid of a diagram, so you really did need to have a diagram, and your diagram for metallic bonding is plus signs with little negatives in a sea of delocalized electrons. So that diagram aids you explain. You have to explain how the bonding in metallic aluminium allows for aluminium to conduct electricity. And the way that it's going to do that is as follows. You're going to say there are positive kernels and a sea of delocalized electrons. The free electrons can flow and conduct electricity. Simple as that. Define the term intermolecular force. Please be very careful. It's not a bond. It is the attraction between molecules. Not between the atoms, not because of sharing of electrons. It's just an attraction between molecules. And ideally you could say in solid phase, but it's fine not to. That's all you needed. At a certain temperature and pressure, fluorine is a gas and iodine is a solid. Use intermolecular forces to account for the difference. So you need to think, what is the difference between fluorine and iodine? Firstly, they are both nonpolar. And therefore, both London. Forces between them. But fluorine is small and iodine is big. Iodine has greater electron cloud wobble, therefore greater intermolecular forces. You need to focus in on what is the difference between those two. The table below shows the boiling points of water and methane. So boiling point of water was 100, methane minus 161. Explain with reference to intermolecular forces in each why the boiling point is so much lower in methane than water. So again, I need to look at the difference. Water has got an H bond force. It doesn't say tell me all about that force. It just says explain with reference to intermolecular forces, not explain the forces. So you went into long explanations for nothing. Water is an H bond force. Methane is a London force. H bond forces are strong. Weak London forces are weak. Therefore, high boiling point and low boiling point. Typical exothermic combustion reactions, such as the burning of methane, is represented by that equation. Lewis structures are diagrams that show that bonding and the lone pairs of electrons that might exist in a molecule. Draw Lewis structures for each of the reactant and product molecules in the reaction above. So what you're going to do is you're going to first have to draw each one of them. And these should have been in your notes. If I have drawn, hydrogen has 1 valence electron, the carbon has 4, which are hybridized. The carbon here has 4, and to make it neat, I've put 2 of them in between there, but really one of those pairs belongs up there, one of them down there. Notice the oxygen has got 2 lone pairs, the oxygen has got 2 lone pairs, and over here, you're expected to know and have learned that water, the 2 lone pairs are not symmetrical, they are on the top of the molecule, and the hydrogens are down at the bottom of the molecule. You are expected in Lewis dots to show who's sharing electrons with whom. So that thinks it's got 8, the oxygen thinks it's got 8, the carbon thinks it's got 8. That oxygen thinks it's got 8, that oxygen thinks it's got 8. Then each of your hydrogens believe they have 2, and the carbon believes it has 8. Then, use Lewis structures in conjunction with the table below to answer the questions. So total energy absorbed is going to be when I break bonds. So let's look at the breaking of the bonds, and that's 2.2.1, and 2.2.2 is going to be the energy to make new bonds. I do know that I have got 2 of these oxygens over here, so it's O double bond O over there, and I've got 2 of the waters as well, so I need to keep that in mind. Then I am going to say the following. Energy absorbed in the reaction is what I have to break, and I have to break 1, 2, 3, 4 C H bonds. So 4 times 413 needs to be broken, and I need to break 1, 2 double bond O's, 498. That turns out to be 1652 and 996, which is 2648 kilojoules. Bonds that I need to make, I'm going to make 1, 2 C double bond O's, 805, so it's 2 times 805. And then I am going to also make 1, 2, 3, 4 new OH bonds. And that turns out to be equal to 1610 and 1856. When I add that up, I land up with 3466 kilojoules. And then they say, what is the change in enthalpy? And your change in enthalpy is going to be the actual heat of the reaction, or the change in energy. So what did I need to do? I needed to take 3466 minus 2648, and that is equal to 818 kilojoules that is released during this reaction. So it's an exothermic reaction. We've got Tajmay, and she tries to paddle a canoe across a river from the point below the bridge to directly across on the opposite bank. Meanwhile, Shira runs across the bridge, and they agree to meet on the opposite bank. However, there's a strong current flowing towards the east, and Tajmay finds the resultant velocity of the canoe is 5 meters per second. So that's what actually happens. That is what Tajmay actually does. And she manages, sorry, there was a mistake there, an angle of 30 degrees to the bank where she left from. Shira runs across the bridge. That's the bridge, so she runs across it. And then parallel to the river on the opposite bank until they get to the meeting point. She runs for 2 minutes. Define distance. Distance is the path traveled, or rather the length of the path traveled. And which of the two of them has the greater distance? Well, Tajmay's got some or other hypotenuse of a triangle over here. That, if you work out the hypotenuse, by the way, which you need to do a little bit later, if that's 60 and that's 50, you get r squared is equal to 50 squared plus 60 squared square root, and r turns out to be 78,1 meters. So Tajmeda is 78,1 meters, and in comparison, you've got 110 meters that Sher does. So Sher travels the greater distance. Displacement is change in position in space. It is an actual definition that you need to know, and since both of them went from this point over here to that point over there, it doesn't matter what path they took, their displacement was exactly the same. Then it goes on to say, if the bridge across the river is 60 meters, which they have just done, and the meeting point on the opposite bank is 50 meters from the bridge, boom, calculate the magnitude of Sher's average velocity. Get your definitions right. If I'm doing average velocity, it is equal to displacement divided by time. And if it's an average, it's total displacement divided by total time. Her displacement was 78,1, and her total time for 2 minutes is 2 times 60, which is 120, and I land up with 0.65 meters per second, which you did really, really badly, so I didn't also look at your direction, but you should have given a direction at 30 degrees to bank. Or if you wanted to, you could have also said, well, I know that east is to the right. So if that is the east, that is the north, then this angle over here is just at 60 degrees. But a direction is appropriate when you are dealing with velocity. A car is traveling along a straight road at a speed v when a dog suddenly runs out in front of the car. In the time interval between the dog appearing and the car applying its brake, the car moves that distance, 29,3 meters. And all that time, it is traveling at v. It hasn't applied brakes, so it's going at a constant velocity or constant speed. It's in a straight line. Once the brakes are applied, bringing the car to rest, so I start that little part of the journey at v and I end it at 0. The front wheels of the car leave skid marks on the road that are 12,8 meters long. So there are two parts to this journey. This is a constant velocity, and this is a deceleration. The acceleration they give me is, the magnitude of the acceleration of the car is 8, and that's magnitude only, so it's not saying that it's slowing down, but I know it's slowing down because it gets to stop at the end of it. Calculate the speed of the car before the brakes were applied. So I'm going to say my u final velocity squared is equal to u squared plus 2as. My final velocity is 0. My initial velocity I do not know. That was before the brakes were applied. Plus 2 times I'm slowing down by 8 over a distance of 12,8. And then I find that my u turns out to be equal to 14,31 meters per second. Then it says calculate the reaction time. So this is, for this whole part of the journey, 14,31 meters per second. And if I'm looking for time, I am going to say that time, it's a constant velocity, so I don't use an equation of motion, is displace or distance over time over velocity. Sorry. The distance is 29,3. The constant velocity is 14,31, and therefore I land up with a time of 2,05 seconds. The velocity time graph below shows the motion of two cars. Car X is stationary at a traffic light, and as it pulls up from rest, it is passed by car Y, which is traveling at a constant velocity in the same direction. How long does it take car X to reach the same speed as car Y? Speed is velocity is on this axis. At 6 seconds, they have the same speed. They have exactly the same reading. It's 12 on there. So that happens at 6 seconds. Which of the two cars is ahead after 10 seconds? If I've got a velocity time graph, the displacement is equal to the area under the curve. So who's ahead? You need to see who's furthest after that period of time. And first I'm going to calculate y, and y is a simple rectangle which is equal to 12 times 10, which is 120 meters. X is a triangle which is half of the base multiplied by the height, which is 100 meters. And therefore, y is ahead, and it doesn't tell you by how much, but it is ahead by 20 meters. What is the acceleration of a gymnast that is free falling in the air? Always 9,8 meters per second squared for acceleration down. Don't give me a minus sign. You need to interpret that minus sign to mean down. If you write minus, I could say that I consider up to be a minus sign. When you use minus signs, you are only assigning a certain sign to any direction. So you have to give me the convention of what you meant by your sign. So that's how you get your 2 marks. Unfortunately, the gymnast is still learning. She manages to bounce up, but she misses the trampoline on the way down. She leaves the trampoline mat with a velocity of 7,84 meters per second upwards. She then slows down, stops in midair, and speeds up in the opposite direction. Let's draw her on a trampoline. She goes up in the air, stops, comes down to exactly the same point and misses the trampoline and does that. So if I work out first part of her distance, I can work out this triangle over here. So it's half base times height, which is going to be equal to a half 0,8 times by the height, which is 7,84. That is equal to 3,136 meters. On the way down, she does this. That's her displacement for her downward journey. So I'm going to say half of base times height, and the base here is 0,8 to 1,5, which is 1,7, right? 0,9 multiplied by a height of 8,82. And I land up with a 3,969 meters. Therefore, what is the difference between the two? This little bit over here, I take 3,969, I subtract 3,136, and I find out that the distance above the ground of the trampoline is 0,833 meters.